Que la que hay, mi gente? Welcome to Virtual Math Masters. I'm your boy, Master Cruz, and today we're going to talk about linear relations and functions. So here we go. The first thing that we want to make sure is that we're familiar with the Cartesian plane. The Cartesian plane is the coordinate plane where we plot some graphs, and if we have four quadrants. Quadrant one, where everything is positive, meaning all x values are positive, all y values are positive. Quadrant two, only y values are positive. Quadrant three, everything is negative, x and y values. And quadrant four, only x values are positive, y values are negative. So these are the quadrants. And when we plot points, we either plot a point in any of these quadrants or on the x-axis or the y-axis. So let's real quick review how to plot points. If I ask you to graph and label each point on the same coordinate plane, and I say point A is 2, 4, then the x value, if you start from the center, right, this is the origin, 0, 0. This says move 2 to the right because it's a positive number, and 4 says move up. Remember, this is x, y, so therefore the x's move left and right. Because it's positive, we're going to move 2 to the right and then 4 up. And here's my point A, 4 up. B is 3, negative 2. So you count 3 to the right because it's positive 3. So 1, 2, and 3. And then you go from there 2 down, 1 and 2. And here's my point B. It's very important that you understand that I don't plot 2 points from the same coordinate plane. Like, for example, I don't count 3 to the right, plot a point, and then count 2 down and then plot another point over here. That is not how that works, right? So it's very, very important that you move and then up and down or left to right and then plot the point. Hopefully you can see point A is in the first quadrant because they're both positive. Point B is on the fourth quadrant. Like I said, x is positive, y is negative. If you were to check point D is in the third quadrant. But point C, you'll have to choose, right, between the second and the third, because where is it? It's on the actual axis. Well, that point is actually not in any quadrant. That point is on the x-axis. That's what we call it. That's the point -1, 10. So any set of ordered pairs is a relation. So this is a relation, this is a relation. All these points, that's an ordered pair. Those are relations. And the way that is a relation is because you have an input and an output. So the x value is always an input and the y value is always an output, right? So let's take a look at example 2 and how this pertains to relations and functions. So here we go. This feels like it's alive and it's not doing what it's I'm telling you, perfect. If I give you a table and I ask you, hey, is this a relation? Well, of course it is a relation because it's represented, every x value has an output y value, okay? So every input is represented as the domain. So this is the same data represented in 3 different types. And now we're going to look at 3 different types to read data. We have tables, but the same table, I can represent it in a coordinate plane or a graph. So I have 4 points, and those 4 points on this table, same data can be represented in a mapping diagram, okay, where you say, okay, if I give you 1, if the input is 1, we call the domain all the possible x values, okay? This is element of the domain, all the possible x values. And if x's repeat, like there's 2 3s, we only write down the 3 here once in the mapping diagram, because when we map it, it's going to go to 2 different outputs, which we call the range. So x values are the domain and y values are the range. X values are the input values, y values are the output values. Think about this as a as if you had a vending machine, you put the money, that's the input value, the output value is whatever you get out of it. So these 3 are the same. Let's take a look at example 2. Example 2 says represent relation E, right, as part A as a set of ordered pairs. So here relation E, I could write it as points, where the first point is -1, comma, and the output is -3. So here it is, -1, comma 3, and it's in parentheses because it's a point. Positive 1, comma 1, because when x is 1, when the input is 1, the output is 1. So 1, comma 1, and then 3, 5, because 3, comma 5. And then say part B represent the same relation as a table. So this is still the same. List all the x values with the corresponding y value. So you just literally copy paste, and that's the same data. C says represented as a graph. Well, I'm going to graph two of them. I'm going to graph -1 to -3. So -1 is the x value. So I'm going to the origin and I move 1 to the left. And then I'm not done yet because I have to move 3 down. 1, 2, 3. So this point down here is the first point. And then 1, comma 1, you just move 1 to the right, 1 up. That's my second point. So that's how you could represent it. Now, how about if I ask you to list the domain? Well, to list a domain, we use it with the letter D. And we say that D equals, we open a brace, and we list all the elements only once from least to greatest. So -1, comma 1, comma 3, and then close your brace. So the domain, it's all the possible x values. The range is all the possible y values. So you just use the same thing and you list them, and that's it. The relations are expressed in set builder notation, but we're going to stay away from that. We're going to represent it in notation like over here. All right. So example 3. State the domain and the range of each relation. So when I look at A and I said, okay, this relation F is -2, comma 4 and 0, comma 4. What is the domain? Well, the domain is the possible x values. So in this case is -2 and 0, right? So my domain is just right here, part A, -2 and 0. Oh, and these 2 points, I didn't see, 2 and 4, so you add 2 and 4. Okay, now what about the range? Well, it looks like the range is 4, 4. They're all 4, actually. So because they're all 4, then you only have to write it once, because I said that if they repeat, you only write it once. So you put the range is, open a brace, and then 4, close your brace. That's the answer. You listed all the elements. How about B? What is the domain here? Well, the domain here changes a little bit. Remember, domain, it's all the possible x values. So as I move from left to right on this graph, the first time that I see any value is down here. And then I see values and I keep going up, 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 or to the right, to the right, to the right, up to point G. So where do I start? Well, it looks like this x value is -1. Remember, we're looking only at x-axis, and it's labeled right here for you. So I'm going to start with my domain from -1, right? X such that -1 is less than x, which is less than or equal to 2. So this in the middle is your best friend. Less than x and less than is just your best friend. You will always use that. Less than x, less than. The first number is where you start, and the last number is where you end. So you started at -1 on the x-axis, and you'll end at +2. Now, notice that, and I'm going to zoom in for this, notice that this point is empty. Therefore, that is not included. That's an open circle. So this is just less than. But this circle is closed. So that's included. So that's less than or equal to. And that's very important that you make the distinction. That's very important that you make the distinction. So the same thing we could do with the range. When you do look at the range, only look at the y values now. So we were going from left to right. Now we're going to go from down up. As I move from the down up, nothing, nothing, nothing until I hit this point. What is the y value of that point? Well, that y value right here is +3. So as I move up, I have a graph, I have a graph, I have a graph, I have a graph until I hit point G again. What is the y value of point G? Well, it's +3. So I move from down, from low to up to high, from down up. I first encounter the graph at -3, and as I keep moving up, my graph stops at 3. So again, less than y this time, because we're talking about the y, less than. You start at -3 and you end up at +3, and this one it's included, so this is going to be less than or equal to. So that's how you find the range of the domain of a graph. Let's do it one more time. If I look at C and I'm only looking at the x-axis, again, I'm looking at all this, all this, all this. There's nothing until I hit 0 for the x value. So, and then this keeps going forever because as you can see, it has arrows that keeps going to the right forever. So x is greater than or equal to 0. All that means is that all numbers are greater than 0, positive numbers, that they're part of the domain. All real numbers is the domain for this graph, and that's how they denote it. You could also just write all real numbers. And the reason is, if I start from the bottom of this graph, what is the lowest possible value that I could get? Well, there's no lowest possible value because this keeps going down forever. It has an arrow. And if I keep moving up, what is the highest possible y value I could get? Well, you might be tempted to say this one, whatever that is, but it is not because it has an arrow, so that will keep going up forever. So the answer will be all real numbers because there's no lowest values. So those are the relations, and that's how you could find the domain and the range. The last thing that we're going to talk about, it's a function. And this, we're going to talk more. You're going to learn more about functions coming up soon. But what is a function? And this is very important. Please write this down in your notebook. A function is a relation in which every element of the domain is paired with one of the only elements of the range. You probably heard me say this before, but this is the reason why I always say that relationships, in order to function, you cannot repeat your x. Math teaches you to never go back with your x. I hope that none of you went back with your x this week, because if not, this is going to suck. All right. But to know exactly how to determine if a function is a relation or not, that will be the next video. I hope that this really helped with relations, and then check out the next video. If you need extra help, please leave a comment and let me know, and I will email you and reply back. If you need additional help, join Virtual Math Masters so I can help you so you never do math alone again.